Our next speaker is Brendan Bouffler from Dell. Brendan has 20 years of experience in the IT industry dealing with large systems in high-performance environments. Brendan joined Dell in 2011 and is responsible for leading Dell's HPC and research computing organisation in Asia. He holds a degree in physics and an interest in testing several of its laws as they apply to bicycles.
And actually, and just recently, some of those laws, in particular gravity, didn't work so good in my favour. Anyway, so look, I've got 20 minutes. It's not a lot of time, and I actually want to say something a little bit, different. And if you guys want to have a discussion around speeds and feeds, come and see me at the stand. We can all talk about speeds and feeds quite a bit. What I do want to do is I want to talk a little bit about what Dell does in science, in particular, in with our scientific customers. And I just want to sort of take just a moment really to reposition where you think Dell lives in the space. So I was having a joke with somebody yesterday that if I took a dartboard and a map of the world, I could throw the dart, and as long as it wasn't something blue that I hit, as long as it wasn't water, I could probably hit a Dell customer who's got 5,000 laptops. So that's almost certainly true. Dell's done a really good job of covering desktops and so forth in the past. But the big breaking news, in case you haven't heard it, is that Dell isn't a laptop company anymore. So what I really want to do is just get your head around some of the stuff that we're doing. Michael Dell made a decision about a year ago, well, actually a little longer than a year ago, that he wanted to create an HPC organisation worldwide in the company. We've been doing HPC for a lot of years, but he decided he wanted to create an HPC organisation to span the globe. And so that's really where I come in. I take care of the Asia portion of the business. I've got some counterparts in North America and Europe, and between the three of us, we have organisations that cover the globe with a full HPC engineering organisation. The last time, and really to put that in perspective, the last time that Michael made a decision to create an organisation, a global organisation inside Dell, he created this thing called DCS. So DCS is this part of our company who make boxes. They make custom specialised hardware for our hosting and our cloud partners, cloud customers. So people like Google, Facebook, Baidu in China, large organisations like that do massive numbers of machines. So it's been interesting because that was really the last time that Michael decided to create this worldwide organisation. And so DCS now, if we pulled it out of Dell as a separate company, it would be the 4th largest compute vendor in the world. So it's grown just a little bit in those few years since he created it. So the next thing that Michael has really turned his attention to is let's go and create an HPC organisation. And so deliberately, the name of the organisation is this here. It's the HPC and Research Computing, right? Which means I'm not necessarily just interested in helping you guys build clusters, although that's stuff that we can help you do. We're interested in what your science is, right? And I want to show a few examples of that. So these are all of our Atlas partners around the world. So Atlas, of course, that is I get to do some cool gigs for my job, and I got to be in Melbourne at the High Energy Physics Conference where the Higgs boson discovery was announced. And so, anyway, and so Atlas is the program that really worked to do all of the compute cycles to actually analyse all of that data and find the Higgs boson. That was basically served up by an army, an absolute stampeding army of these boxes. There's one up on our stand. You can see it on the, just on the podium up on our stand. It's a 2 motherboard box, 4 processors on each motherboard. It's an AMD system. This thing is the bread and butter of what processed all of the data in the Atlas program, right? And that was because Michael actually got personally involved in this one. It's interesting working inside Dell with, the guy who founded the company is still there. It's a bit of a cult of Michael. But what he can do is he can lead us in some very interesting new directions. Michael got very, very seriously involved, in the project that CERN was doing for the LHC, and decided to actually invest a chunk of his own money and a chunk of the company's money in trying to pursue that. right? So he's interested from a science point of view. We've got a few other interesting things that we get involved with as well. So CSIRO Urban Monitoring Project. Has anybody heard of this? You guys heard of this? This is really cool science, right? They're taking a lot of high-res aerial photography of urban areas and then doing a hell of a lot of data processing of that, and that's, you know, it's using a whole pile of clusters that we help CSIRO build, but it's processing a lot of data to work out what land use is in urban areas. You know, there's a lot of future projects that can come out of that. So it's an interesting bit of science. A couple of our clusters were responsible for doing most of the modeling for the landing of the Discovery probe on Mars a few months ago. And, you know, we didn't do it was NASA that did the serious compute here. We provided the hardware for it, but this is really important to us because it reminds us why we're in this business, right? It reminds us why we're actually trying to do this. And in fact, the reason is because we have this nerd here called Jeff Layton on my team in the US. Jeff actually is a rocket scientist. Have you ever met one? It's really cool. He really is. So his PhD is in aeronautical and astronautical engineering. And, you know, he got us involved in that project. This is a driver for the reason we get in this business. We've also got involved in a pediatric cancer research program in the US. So this happens out of a group called TGen, a company called TGen, a hospital in the Midwest and a hospital in the Rockies. What these guys are doing is they take a biopsy of a kid's cancer. You know, and these are usually kids that have got about a year to live. But they take a biopsy sample out of the cancer, they characterize it, complete molecular characterization. That's really where the compute cycles go, is in this part here. And then what they're doing is they're trying to actually tailor drug treatment for that cancer based on the cancer's DNA, based on the cancer's actual individual structure. So what they're aiming to do is that the moment when we first started getting involved in this project, it was taking around about 3 or 4 months of compute to actually do that characterization. So for a kid that's got 12 months to live without treatment, 12 weeks or 16 weeks is a pretty big deal. So the involvement that we had was to try and work out how to shrink that compute cycle, how to shrink it from 12 weeks down to, say, 12 hours. And 12 hours was the target. Right now we're at 19 hours, which we're pretty happy with, because it means that within about a day of getting a biopsy, we can actually put the kid on the right drug treatment to actually target the cancer that he's got. So it's, you know, massively increased the survival rates of these kids, right? So, and we're still trying to squeeze it down a little bit further, but we're doing all of this with like a rack of compute. So this is really interesting science, and we got into this because we got this guy, Glenn Otero, another nerd of ours. He's a microbiologist. He's got a PhD in microbiology. This is his field, and he's dragged Dell into this field. Not dragged us, but he's got us into this field and got us involved in these projects, right? So what I want to say to you is we're not a laptop company anymore. So this is some really cool science they're doing. All around the world, and it goes back to that discussion we had earlier, you know, where I said, you know, throw a dartboard at a map and you'll hit a Dell customer. We're actually, by unit shares, we're the second largest HPC vendor in the world in terms of HPC servers. What that means is that you guys are actually buying a whole lot of our stuff and doing stuff with it, which is really cool, right? We want to try and find out how we can help you do more with that. We are interested in your science. It's not, you know, we all play in the top 500 game, right? And, you know, there's the top 500 projected teraflops and petaflops for this year. It's very interesting. We've got a machine that's going to be turning up there next month, you know, when we're all in Salt Lake City at supercomputing. We'll see the announcement of this machine. Here's a bit of a preview of what it looks like. This is going to be around about, you know, when it's actually finished and fully commissioned in February, it'll be around about 9.5 petaflops. Right, so this is a machine that we built for TAC, which is actually Michael Dell's old university. And it's actually where he started the business. on campus at the University of Texas. But so they get kind of good pricing. Anyway, so so we all play in the top 500. The stuff that is really interesting to us, though, is actually not the top 500. It's the next 5,000. Right, and that is really what Dell's HPC focus is about. It's the next 5,000. Just by way of a scale comparison, here's the #1 machine on the top 500 back in 2002. It's the Earth simulator. Everybody here would remember the Earth simulator, right? We all sort of looked at this huge Japanese machine and went, "Wow!" Right? 40 teraflops, costs 480 million. So we can do 40 teraflops now in a rack of our blades for less than 480 million. I'll kick it in for 240 million if you like. But it's a square meter, it's 30 kilowatts. It's not 3,000 square meters, which is like, half a football field, and 6 megawatts. We've all seen these comparisons before, but what we're interested in terms of our focus on the next 5,000 is what we're interested in is what kind of science can you do when you've got a machine similar to, the largest machine in the world, sitting under your desk or at the end of the hall that you can suddenly do your compute on, right? Take a quarter of this, so you've only got 10 teraflops, right? So, if you would have been able to get a quarter of the CPUs on the Earth simulator back in 2002, I totally respect you. You would have been breaking, miracles to be able to get that kind of access to that machine back then. So think about the science that you can do on something that's this big, that's a cluster in a box under your desk, where instead of having to go and submit a job and wait for 3 weeks to get the results back when it got scheduled eventually, you can actually get the results back before lunch, and then you can change your input parameters before you go to lunch, and then see what it's like mid-afternoon, and see what happens to your science when you change the cadence like that. That's why we're interested in the next 5,000. That's why we got involved in Atlas. It's why we got involved in the pediatric cancer work. It's why we get involved in all this stuff, right? So at the end of the day, the stuff that really drives us is the science that you guys are doing. We are a bunch of geeks, after all. Glenn and Jeff are good examples. I'm the closest thing you get out here. I'm a failed physicist. But this is why we do it. You guys are pretty much why we do it. So I think that's about all I have to say. If any of you guys are going to be around at supercomputing, please come and see us. Come and see TAC. It's the big green box, big green machine. It looks really cool. But, come and talk to us about your science. We're really keen to talk about what it is that you're doing, why you're doing it, how it can help you solve the problems. It's a much more interesting place to start for us than how many boxes can we sell you. So that's pretty much all I've got to say. Anybody got any questions? Yeah?
What's the percentage of the business with HPC and Dell now? And what do you think the future target would be?
Let's see. So if you just take the scientific and the research stuff out, it's probably around about, depending on the country, it's around 5 to 10% of our business worldwide. So I take care of a lot of countries in APJ, so everything between Pakistan and New Zealand, probably not a high proportion in Pakistan, higher proportion in New Zealand, and a lot of variation in between. China keeps me really busy, right? So, probably between 5 and 10%. Realistically, where are we going? The interesting thing with, say, things like OpenStack, technologies like OpenStack, very interesting stuff because, we've got big leadership in the OpenStack space. We've always had, we've been out writing code, contributing code back to the OpenStack code base for a long time now. We've got folks on the board of the OpenStack consortium. I was sitting with a few folks last night talking about that. We're working with Polly up the back at Monash to deploy the Nectar node, to deploy Monash's Nectar node. But, so we've always had this big leadership in OpenStack. OpenStack is suddenly becoming, because of Australia really, it's becoming very interested in a research computing cloud, right? But we're getting a lot of interest from around the world in that as well. So, that's something that we're going to keep working on. And frankly, I think, given the general migration of the industry to cloud, I think probably that portion of the business that I'm going to be really involved in is just going to get bigger and bigger. So 5%, 10%, I don't know, 20, 50, who knows? It's going to get larger. It's growing rapidly, right? It'd be great for my department, absolutely. Get back to me in a couple of years. Come and visit me on my yacht in the Caymans. Yeah. But no, look, if anybody's got any comments or questions, please come back and see me. I'll be up at the stand all day. And if there's a speeds and feeds discussion to be had, happy to do that as well. Thank you.